अच्छा, we did the Shatter principle, nothing else. तो वो सब ने किया था. We did questions on we did past paper questions as well. So now we're going to do KC. Okay, we did all of this. Now what we're going to do is we're going to do KC. KC is K, and it only applies to, and this is important, that KC is only going to be, it's not applicable to a reversible reaction. It's applicable to a reversible reaction that has already reached equilibrium. Kc is the ratio of the product concentration divided by reactant concentration. So Kc is directly proportional to products and inversely proportional to reactants. So what happens is, okay, whenever you have this equilibrium, so you'll have some products formed and there'll be some reactants. But whatever happens, the concentration of the two things would stop changing. The H2 reacts with I2 to produce HI, but at the same time, the HI decomposes to produce H2 and I2 back again. And a product बहुत ज़्यादा भी हो सकते हैं, कम भी हो सकते हैं. So that is, the equilibrium position could be anywhere. You could have a lot more products, you could have a lot fewer reactants. But there's going to be a ratio that is going to exist, and that ratio would give you an idea about the equilibrium position. Okay, if the value of the concentration of the products and reactants, if it's large, so what does it mean? Is the equilibrium favoring the products or is it making more reactants? क्या होगा if it's large? Mikhail, Munir, Abza, क्या होगा?
The concentration would be a lot, maybe.
For products or reactants?
For both, I believe, no?
If it's large, when would it be large?
Oh, when the product's concentration is more than the reactants.
So that means there's going to be more products. So there'll be more products, right?
Yeah.
And
Yes.
and vice versa if Kc is small. So
then
that
the reactants will be more.
so in that case you'll have more reactants, right? So this is a pretty vital information that you'll get about this container. Okay, remember the equilibrium position could be anywhere. It could be favoring the products, it could be favoring the reactants. So Kp and Kc. Kc is the ratio of the product concentration divided by reactant concentration. Kp it only applies to gases. Concentration is the same as it's proportional to pressure for gases. If you have a more concentrated gas, there are more particles. So there's obviously going to be more pressure as well, because there's going to be more collisions with the walls of the container. So Kc and Kp are kind of the same thing. It's the ratio of the product's concentration divided by reactants, or the pressure of the products divided by the pressure of the reactants. But we're going to talk about Kp later on. There's only one thing that changes. It's a constant. This ratio is a constant, and it remains a constant. Any change in concentration or pressure, Kc would always remain a constant. क्योंकि क्या होता है कि where would the equilibrium shift if I have a reaction? If I go in and decrease the reactants, what would the equilibrium do? Where would the equilibrium shift?
Go backwards.
And it will produce more reactants, right? So वो ratio maintain रखेगा कि if I try to decrease the reactants, it's going to make the quantity bigger again. It's going to produce more of them. Is that clear? So the equilibrium, what it does is it does not allow the ratio to change. Okay, it wants to maintain that ratio. If I have, and the same thing happens like water wala jo example hai. Okay, I mean, there's a ratio, amount of steam and the amount of liquid water, right? If I go in and I remove all the water vapors would condense and they would produce more water. So there would be a ratio that would be maintained in this equilibrium. मतलब vice versa, अगर मैं water vapors खत्म कर देता हूँ, if I remove all the water vapors, So the liquid water would evaporate and it will produce more water vapors again, and the ratio or the quantity, the ratio of the products and reactants would kind of be maintained. The ratio jo hai na, equilibrium will try to maintain it. So no matter what you do with pressure or with concentration, this ratio is going to be maintained. The ratio will be disturbed only, ये जो constant है ना, it would only change if you change temperature. अगर आप temperature change करते हो ना, फिर क्या होगा कि if I, let's say, increase the temperature, then I'll only have steam. There wouldn't be, I mean, the ratio will get disturbed. Okay, if I take the temperature to a very high temperature, then all I'll have is the product. There will be no reactants. Okay? I mean, in this particular case. So is this idea clear that it only changes with temperature? Is that clear? Yes or
Yes,
no?
sir.
अच्छा, and then you have कि वो सारा तो लिखा हुआ है कि KC value is large, उसका क्या मतलब है, ठीक है? अच्छा, and also remember कि जो term concentration है ना, that only applies to solutions. So I think we have mentioned that previously as well, कि it only applies to one second. अच्छा, it only applies to solutions या फिर ये ना आपकी जो gases हैं. For liquids and solids or anything that's in large excess, the concentration is a constant. It's always taken as 1. Because concentration क्या होता है? Concentration is the spacing of the particles. Like if I have a container, so it's the spacing of the particles. If the particles are really close together, that would mean it's concentrated, right? If the particles are like really far away from each other, so then that would mean it's not concentrated. So concentration is like spacing. The spacing, the distance between the particles is changing or not. So liquids or solids where the distance is never changing. Like if you have a solid, the particles are always tightly packed. Okay, so the spacing is not changing. The spacing only changes either if the particles are in a solvent or if they are in gaseous form. क्योंकि उसमें spacing change हो जाती है. Liquids or solids में it doesn't change. अगर water liquid है, so all the water molecules would be right next to each other. The spacing would never change. Even if you add more water, the spacing remains kind of the same. And the same thing applies to solids. Is that point clear as well? You clear?
Yes.
Oh yeah, Adhra, this is an important point. Solid key concentration is going to be taken as a constant. It's going to be taken as 1. Liquid होगा कोई तो उसकी भी concentration is always going to be taken as 1. So the first thing we'll do is इसको हम यहाँ पे कर लेते हैं. Now the first thing we'll do is yes.
So you just said that concentration applies to solutions and gases, right?
Yeah.
Then why is solid equal to 1 if it doesn't apply?
नहीं, एक तो पहली चीज है कि you do agree to the fact that solid concentration does not change, right?
Acha. Okay, like that.
ठीक है.
Yeah, okay.
Because the particles are always tightly packed. It never changes, right?
Yeah.
So the spacing never changes. But the concentration idea है ना कि concentration is how closely packed are they or how loosely packed they are. I mean, how far apart they are, right? कि अगर मैं थोड़ा सा नमक डालता हूँ ना पानी में तो particles उसके नमक के बहुत दूर दूर होंगे. They'll be very far apart. But if I add more of them, then the particles would still be kind of far apart, but they would be closer to each other now. Lekin if it's a solid, it would, I mean, they would always be tightly packed. Achha, the reason that you take it as 1 is कि 1 से ना expression को कोई फर्क नहीं पड़ेगा. Like if I write the KC expression and if I take it as 1, then basically I'm just multiplying it by 1 or dividing it by 1. So the expression would kind of remain unchanged. ठीक है, if I had taken that as 0, तो वो आपका expression ही खत्म हो जाता, ठीक है? As anyways, the first thing is you have to write the expression. So whenever you have an equilibrium reaction, तो उसका जो expression है ना, that is this, कि if you have H2 and I2 react, and this is your product, this is your reactant. So it's HI concentration divided by H2 concentration into I2 concentration. Remember, the coefficient becomes the exponent. What that means is कि जो 2HI लिखा होता है ना, इसको आप इस तरीके से भी लिख सकते हो कि this is 2H है. So what was Kc? Kc was proportional to the product concentration, so it's HI concentration into HI concentration. So automatically क्या हो जाएगा? It's going to become HI squared divided by, it's inversely proportional to the reactant concentration. This is your reactant, this is your reactant. So it's inversely proportional to H2 and I2. तो वो squared इसलिए आ जाता है कि you obviously don't write equations like this. कि अलग से HI नहीं लिखते. What you do is you just write 2HI. तो इसलिए the coefficient becomes the exponent. ये अगला वाला है, this is N2 plus 3H2 produces 2NH3. So it's going to be NH3 concentration squared, that's your product, divided by your reactant, which is N2, and the other one is H2, and that's going to be cubed. और वो multiply हो रही होंगी, ठीक है? Make sure there's the reactant concentrations are going to be multiplied. Or the other question is they're going to ask you about the unit as well. तो unit का किस तरह करोगे कि unit is just like physics. Concentration unit क्या होता है? It's mole per dm cube. So it's going to be mole per dm cube squared divided by mole per dm cube into mole per dm cube, and that's cubed. Now it's very hard to simplify in terms of mole per dm cube. So what you can do is, instead of using mole per dm cube, just use x. कि mole per dm cube जो है ना वो x है. So it's x squared divided by x into x cubed. उसको simplify करो, x to the power -2 आ जाता है, and put mole per dm cube. Now replace it with mole per dm cube. So x जो था वो mole per dm cube था, ठीक है? So instead of solving it using mole per dm cube, just use x. And it comes out to be x to the power -2, mole per dm cube -2, and that gives you mole -2 dm6. Every time the unit is going to be different. कभी कभार unit होगा भी नहीं, ठीक है? For example, over here, mole per dm cube squared divided by mole per dm cube into, so it's x squared divided by x into x. Everything cancels out. So no units, and it is considered to be dimensionless. Yes, so 3 के ये उसका expression है, product concentration SO2 squared, O2 power 1 divided by reactant SO3 squared. So it's x squared into x divided by x squared, comes out to be just x. X is mole per dm cube. Is that clear?
Yes.
अच्छा, अब अगला part जो है, that is the part that is kind of difficult. And that part is कि I'll इसके ऊपर ही करें कहीं और, एक second. अच्छा, that part is you'll be asked. I'll just rewrite everything. Let me just rub this off. Just hold on a second. अच्छा, इसके ऊपर ही working कर लेते हैं. अच्छा, now this one. Okay, that's your question. Questions would be about calculating the value of Kc. That's the first type of question. What will happen in that is you'll have उसने ना initial moles दिए होंगे कि there's 0.4 moles of H2 and 0.4 moles of I2, and they're mixed in a 2 dm cube container with 0.1 moles of HI, right? So ये container, and what he's doing is it's a 2 dm cube container, this one, ठीक है? So it's a question में लिखा हुआ है, it's a 2 dm cube container, and he says कि उसमें ना 0.4 moles of H2, right? So 0.4 moles किसके? H2 के, and there is 0.4 moles of I2, so 0.4 moles of I2. They are mixed, and there is 0.1 moles of HI as well. That's part of it. अच्छा, HI भी बीच में ना मिक्स हुआ है. अब क्वेश्चन ये कि if you mix them together, there obviously is going to be some sort of, so there's obviously going to be some sort of reaction. If you mix them together, there's the H2 and I2, they would react, and there's going to be a reaction. Maybe there is some forward reaction. Agar the reaction forward hota, I don't know if there's going to be a forward reaction, but let's assume that there is a forward reaction. when I mixed 0.4 moles of H2 at the beginning, it's not at equilibrium. I've just randomly mixed them together. So अगर यहाँ पे 0.4 moles है, 0.4 moles है, and they're producing 0.1 moles of HI. तो अच्छा इसका मुझे बताओ कि 0.4 moles को 0.4 moles के साथ mix किया. If there is some forward reaction, what would happen to the quantity of H2 and I2? Would it decrease or would it increase?
Decrease.
Decrease, because they would react, right? If there is some forward reaction. So some of the H2 would react with some of the I2 and it would turn into some amount of HI, right? तो ये दोनों जो है ये कम हो जाएंगे, इनकी quantity थोड़ी सी, they would decrease. और उनकी quantity थोड़ी सी, it would increase, right? So 0.4 said it would be lesser than 0.4 and this would be greater than 0.1. Or maybe there's a lot of backward reaction. So if there's kind of a backward reaction, what will happen in that case? कि अगर reaction backward शुरू हो गया इनके बीच में, तो HI कम हो जाएगा and H2 and I2 would increase, right? अच्छा, so we don't know what's going to happen. I mean, we can't tell what's going to happen. I mean, I don't know how the reaction behaves. And I don't know what the value of Kc is. Because the value of Kc would give us a hint. कि अगर Kc large होता ना, so what that would mean is that there's going to be more product. So this value should be bigger, and this value should be lesser. But I don't even know the value of Kc. But they've given us some hint. They've said that they're mixed after several days when equilibrium is reached. So now equilibrium has been reached. So there's another row, and this one is for equilibrium. So when equilibrium is reached, it is found that 0.3 moles of HI are present. So यहाँ पे ना, after several days, you found out that HI के, sorry, not I2. Equilibrium के ऊपर ना HI के, the moles of HI are 0.3 moles. तो डाले आपने 0.1 थे, and all of a sudden you found कि at equilibrium you have 0.3 moles. अच्छा, पहले तो एक चीज याद रखना कि the initial moles could be in any ratio because you're the one who's adding it. Either आप 0.8 डाल दो, it doesn't make a difference. I mean, you're putting moles in the container, so you could put them in any amount whatsoever. I mean, if you put 0.4 moles of H2 and 0 moles of I2, that would work as well. So remember, these moles, they don't have any ratio because they're just randomly mixed together. Equilibrium moles are also not going to have any specific order or ratio. But ये जो बीच वाला column, I'm interested in this middle column, which is how many are reacting and how many are getting produced. So if you had 0.1 moles of HI and at equilibrium you found out you had 0.3 moles, so what does that indicate? कि the extra 0.2 कहाँ से आया? There must have been a reaction, right?
Yes.
And that reaction must have produced those extra 0.2 moles, right? You clear?
Yes, sir.
Yes.
So that is something. So they'll give you a hint about the equilibrium moles. We're interested in this middle column. Like now I know that 0.2 moles got produced because I had only added 0.1. और यहाँ पे I found out that there's 0.3. So 0.2 एकदम से कहाँ से आ गए? That means 0.2 must have been produced. तो अब ratio लगाओ कि अगर 0.2 produce हो रहे हैं, if 0.2 are getting produced, ठीक है? So now we're going to use ratios. So 0.2 are produced. So what is the ratio? How many of them would have reacted if 0.2 are getting produced? It's 2:1:1, right? To produce 2, you need to have one iodine and one H2 reacting. So to produce 0.2, how many would have reacted? 0.1, right?
Yes.
Or इसके भी 0 point? So ये clear है?
Yes, sir.
Yes.
तो इसका मतलब है यहाँ पे 0.1 moles खत्म हो गया ना, they have reacted, right? And इधर भी 0.1 moles have reacted. minus sign का मतलब है कि react हो गए, they're gone, they're finished. So 0.1 reacts with 0.1, and you'll have तो आप मुझे बताओ कि equilibrium पे क्या moles होंगे? 0.4 were initially added, 0.1 are gone. So your equilibrium moles would be
0.3.
0.3 moles. And this would also be 0. This would also be 0.3 moles, right? You added 0.4, 0.1 are gone, so you're left with 0.3. Is that clear?
Yes, sir.
Yes, sir,
Yeah.
it's clear.
So you're going to use these moles. You can remember the equilibrium quantities are going to be put into the Kc expression. And also remember, for equilibrium, the Kc expression, you need concentration. You don't need moles. So how do you find concentration? It's moles over. It's basically moles over volume. So concentration is moles divided by volume, right? So volume is given, the container volume is given as 2 dm cube. So I'm going to divide everything by 2 dm cube, because I'm looking for concentration. So I'm going to divide by 2 dm cube, and then I'm going to put it in the expression. अच्छा ये गलत हुआ है कि हाँ point. So why did I previously use 0.15?
Sir, 0.3 का half.
अच्छा हाँ
0.15.
ठीक है. So it is 0.15 squared, right?
Yes.
So it's HI squared divided by H2 and I2. And I think the whole thing would get cancelled out, and it would come out to be exactly 1. So Kc comes out to be 1, and it's not going to have any units. Is that clear?
Yes.
Yes.
As a core question, the same question. I'm just in this one, I've only changed the table. So I mean, we can get rid of the previous working. 1 second. So it's the same reaction except ये दिया हुआ है. अच्छा ये कर लेते हैं. So only this is given. So let's start with this. Okay, initially H2 0.2 moles, I2 0 moles, and 0.8 moles. I mean, the table would not be drawn for you. Okay, so they'll probably just give it in the written form. So you've got 0.2 moles of this, 0 moles of this, and 0.8 moles of this. After several days, जब equilibrium पे देखा ना, तो you figured out that you have 0.3 moles of I2. तो जब 0 डाला था और अब 0.3 पड़ा हुआ है, तो इसका क्या मतलब है? What does that mean? That how much got produced? Extra कितना आ गया?
0.3.
0.3.
तो where is the? तो इसका मतलब reaction इस direction में गया ना, right?
Left there.
Because 0.3 got produced. मतलब वो extra आ गया 0.3, right? So if now use ratios. If one of this is produced, one of H2 is also produced. So how much H2 would be produced in this reaction? कि अगर हम कह रहे हैं कि 0.3 प्रोड्यूस हुआ है, तो इसका कितना प्रोड्यूस हुआ होगा?
इसका भी 0.3.
ठीक है, so that is also going to be 0.3. That would be produced. तो यहाँ पे भी ना एक्स्ट्रा 0.3 जो है ना, वो हो गया प्रोड्यूस. अच्छा, फिर यहाँ पे how much of it would have reacted to produce 0.3? How much of this would have reacted?
0.6.
ठीक है, double would have reacted. It's 1:2. So 0.6 would have reacted according to the ratio. It's 2:1:1. So 0.6 must have reacted. तो यहाँ पे ना minus हो गया 0.6 have reacted. So बचा कितना है? You had 0.8 and 0.6 have reacted. So you're left with how much? You're left with 0.2.
Yes.
और उधर जाके 0.2 पहले थे and 0.3 extra have been produced. So you're left with how much?
5.
0.5 moles, right? So all you have to do now is remember equilibrium moles are going to be put into the Kc expression, and you'll find the value of Kc, which is going to be product concentration squared divided by H2 and I2 concentration. So it's going to be HI squared and divided by H2 concentration and I2 concentration, right? And one thing I need to add is, okay, sometimes you can get away with not using. I mean, you don't have to use. इधर ही लिख लेता हूँ नीचे, कहाँ पे question. So you don't always have to use concentration. So if Kc has no units, I mean, no units means that if the number of terms in the numerator and denominator are the same, so you're allowed to use moles instead of calculating the concentration. Why? Because the volume part will get cancelled out. Okay, so I'll just quickly explain what will happen is कि concentration कैसे निकालते हैं? It's moles divided by volume, right? So if I try to find, let's say the volume is V. So it's going to be HI kitna? It's 0.2 divided by V squared, right? So this one is 0.2 divided by V, and that's going to be squared. And then it's going to be divided by what? Divided by 0.5 divided by V, right? That is H2, and divided by I2, that's 0.3 divided by V. So अगर ऊपर और नीचे terms same है, so what is, you're getting V squared on top and you're also getting V squared at the bottom. The V part is going to get cancelled out. ये जो V's है ना, the number of terms in the numerator and denominator are the same, so they would get cancelled out. So there's no point in finding the concentration if it has no units. तो वो volume वाला part वैसे ही cancel out हो जाएगा. So there's no point finding the concentration. That you'll just add an extra step. So use moles instead of concentration only in that case. That's the only exception. Is that clear? Otherwise, you would have to find concentration. So that's the only exception. Is that clear?
Yes.
Yes.
Achha, directly we'll jump to the questions, the Kc questions, and we'll try to solve. तो हर दफा इसका जो ये वाला question है, that's first time calculating Kc, that would kind of be the same. कि ये वाला question है. So they won't give you a table. Here's the question. अच्छा, so they won't give you a table. तो आपको खुद ही बनाना पड़ेगा टेबल. रफ सा बना लो कि पहले तो इनिशियली उसने क्या कहा है? उसने कहा कि 2 moles of H2, so इसके 2 moles है, and 3 moles of iodine. So this one has 3 moles, right? They are mixed together, so that means there is no HI initially, right? फिर वो इक्विलिब्रियम की आपको कुछ बताएगा कि जी इक्विलिब्रियम के ऊपर ना, it was allowed to reach equilibrium at a fixed temperature. The container had a fixed volume. At equilibrium, there were 2.4 moles of iodine. तो equilibrium पता लगा है, इसके moles तो पहले पता थे, अब equilibrium पता लगा है, it's got 2.4 moles, right? So what happened? कम हो गए, ज़्यादा हो गए? Like you had 3 moles, right? Now you have 2.4. So how many ended up getting used up? How many got used up or reacted? कितना आ रहा है, Hamza, Munib? आवाज आ रही है? Mikal?
Yes, sorry. 0.6 was used,
So that means 0.6 must have
reacted.
reacted. They would have reacted, right? Or react
Yes.
उन्होंने क्या किया? I mean, must have produced HI, right? So if 0.6
Yes.
of this is reacting, तो H2 के कितने react करेंगे? It's 1:1.
0.6.
So उसके भी 0.6 would have reacted, right?
Yes.
तो उसके moles कितने बच गए? 2 डाले थे तो 0.6 react कर गए तो पीछे कितने बचे? That's 1.4 moles, right?
Yes.
और फिर 0.6 react कर रहे हैं 0.6 के साथ तो how many would be produced? 1.2, right?
1.2. Yes.
And they're getting produced. So शुरू में तो थे ही नहीं 0 moles and now you have 1.2 getting produced. So what are your equilibrium moles? That's going to be 1.2 moles, right?
Yes.
तो बस इसको यूज करके this one will have no units क्योंकि numerator terms and denominator terms दोनों साइडों पे अगर moles बराबर होते हैं ना तो just remember if you have 2 moles and this is also 1 and 2 moles. If you count the moles on both sides if they are equal, so Kc will have no units. वो करके देख लो, it's going to be, so Kc expression would be 1.2 squared HI squared divided by 1.4 times 2.4. Is that clear?
Yes.
तो वो जो भी आएगा. अच्छा इसका वो कह रहा है कि it's the same initial moles. कितने initial? That's 0.2 moles of H2 or 0.5 moles of iodine and is established. हाँ तो बस ये 0 है. Equilibrium पे कितने हैं? Equilibrium पे you had 0.26 moles of HI. So you had 0.2, 0.15 until equilibrium is reached and it was found कि HI had 0.26 moles. तो अब मुझे बताओ कि अच्छा सॉरी ये 0.15 है, सॉरी मैं भी वो गलत किया. अच्छा anyways 0 थे, 0.26 moles are present at equilibrium. So how many got produced or reacted? But how much HI? 0.26 produce हो गया, right?
Oh, yes.
ज्यादा हुए ना, तो ज्यादा हुए तो that means produced. That means the reaction is going in. अगर एक साइड पे produce हुए, the other side वहां पे कम हुए होंगे ना. So 0.26. Let me correct that. 0.26. So this is 0.26. So how much I2 would react to produce 0.26?
0.13.
तो इसका मतलब यहाँ पे 0.13 must have reacted. उसके भी 0.13, right?
Yes.
So what are your equilibrium
Yes,
moles?
sir.
So what are your equilibrium moles? 0.2 were initially added. 0.13 are
Would it
gone.
be D, sir?
0.07.
ठीक है, और 0.15, 0.13 are gone, so that's 0.02. So it's going to be C.
Oh, okay.
Clear? 0.26 squared divided by 0.02 into 0.0. So this one. ठीक है?
Yeah.
अच्छा इसी तरह के क्वेश्चंस अभी पहले कर लेते हैं कि this one is slightly difficult but it's kind of the same thing. It's saying कि असल में इसमें trial and error है. पहले simple, let's keep things simple for a while. This one is this one. Let's do this one. So इसमें I'll just rewrite the reaction. It's 2NO2 and it's in equilibrium with 2NO plus O2. अच्छा इसमें क्या हो रहा है कि वो कह रहा है कि initially 4 moles, ये लिखा है 4 moles जो है ना NO2 के, so that's your initial 4 moles. तो इसका मतलब बाकी क्या होंगे? That's 0 and 0, right? So they were
Yes.
put into a container. Equilibrium mixture contained 0.8 moles. So at equilibrium, the O2 contained or found was 0.8 moles. So how much O2 got produced? So that is 0.8, right? 0.8 extra produced हुआ ना? So that means the
Yes, sir.
reaction is going in the forward direction. So if 0.8 of O2 is getting produced, तो इसके कितने produce होंगे?
1.6.
ठीक है, so 1.6 of this would also be produced क्योंकि it's 1:2. And if 0.8 are getting produced, how much NO2 would be reacting?
So 3.2 maybe. Like you subtract 0.8.
नहीं. To produce one, two react, right? Use ratios. It's 1:2.
Oh yeah.
So
Then would it be 3.6 then?
0.8 is getting produced. It's 1:2. So
So would it be minus 1.6?
1.6 must have reacted, right?
Okay. Yeah.
So the moles that would be left over here would be 2.4 moles,
Yes.
not 3. So it's going to be 2.4 moles, and this would be 1.6 क्योंकि शुरू में तो थे ही नहीं. अच्छा, anyways, so just remember the equation deals with ratios. I mean, it's not addition and subtraction, it's actually ratios. तो मतलब ये addition subtraction वाला काम नहीं करना, it's ratios, and the ratio only applies to the middle column over here, not to this and not to the bottom one. ये मैंने पहले भी explain किया था कि you can put any amount of moles into the container, they will not have any specific ratio. The equilibrium moles will also not have any specific ratio. The ratio in the equation applies to anything that's taking part in the reaction. So अगर 0.8 बन रहे हैं ना यहाँ पे, you had 0 and now you had 0.8, so that means 0.8 got produced. So इसके 1:2 के मुताबिक that's 1.6 must have been produced, and 0.8 ratio 1.6, so 1.6 over here must have reacted to produce 0.8. तो वहां पे minus 1.6 हो गया, ठीक है? So which one is the correct expression now? अच्छा,
D.
इसमें पहले तो इसमें बताओ कि do you have to do the extra step and find concentration? Kc की units होंगे, and remember Kc uses concentration, not moles. पर तो इसका will it have units or will it not have units? उसका मैंने क्या बताया था?
It will.
Right?
It will have units,
It
right?
will. Yeah.
क्योंकि इधर 3 moles है न्यूमरेटर में and डिनोमिनेटर में 2 terms हैं, 2 moles है, तो वो cancel out नहीं होंगे. मैंने कहा था the expression cancels out only if the number of moles on this side and this side are exactly the same. तो वो volume वाली term cancel out हो जाती है. In this case, the volume term will not get cancelled out, so you would have to find उसको container का volume इसलिए दिया हुआ है उसने. It's a 1 dm cube container, so moles divided by volume, moles divided by volume, and mole per dm cube, right? Moles divided by volume. Is that clear? तो
Yes,
खैर 1 से तो डिवाइड करने का कोई फायदा नहीं है, लेकिन but remember this was an essential requirement. If this were 2, तो फिर वो 2 से करना पड़ता. But anyways, your answer would be what?
D.
So it's going to be D. 1.6 squared divided by into O2 divided by NO2 squared. So it's going to be D. Is that clear?
Yes, sir.
So we already see another question. ये वैसे Kc का ही है. He's asking you to calculate Kc. तो उसने कहा कि initial concentration. So it's basically the reaction is X in equilibrium with 2Y. ये वाला. तो he's saying कि initially ना 0.5 mole per dm cube है. So initial is given at 0.5 और वो 0 है. तो container में there is no Y. And then he says when equilibrium has been reached, the concentration of X has fallen to 0.25. So equilibrium जब reach हुआ है ना, तो इसकी concentration 0.25 हो गई है. तो इसका क्या मतलब है कि how much reacted? कम हो गया. तो इसका मतलब है 0.25 are gone. They have reacted. And they're gone, they've reacted to produce what? To produce Y. तो Y कितना बना होगा?
0.5.
ठीक है, 1:2 है. तो if 0.25 have reacted, तो दूसरी साइड पे 0.5 must have been produced. So your equilibrium moles would be 0.5, right? So ये दो आपके पास आ गए 0.5 and 0. And what would be the expression? It's going to be 0.5 squared divided by 0.25,
25.
which is going to give you 1. Kc would have a value of 1. Clear?
Yes, sir.
फिर इधर भी कर लो ये 1 mole of silver ions. Silver nitrate has silver plus 1 ions. FeSO4 has Fe plus 2 ions. So 1 mole of this and 1 mole of this are mixed. ये 0 है और ये भी 0 है. उससे क्या जब equilibrium reach हुआ ना, there was 0.44 moles of silver ions. So silver ions जो है ना वो 0. So how much got used up? 0.
0.44.
If I-
0.5656. Yeah, because 0.44 is left.
ठीक है, तो इसका मतलब रिएक्शन फॉरवर्ड गया ना 0.56 have reacted, right? और 1:1 है, तो इसके कितने रिएक्ट होंगे?
56.
और वो आगे जाके प्रोड्यूस कितना होगा? If 0.56 reacts with 0.56, it's going to produce 0.56 of this and 1:1 है ना?
जी.
So it's going to be 0.56 and this would also be 0.56. So so what are your equilibrium moles? 1 mole डाले थे, 0.56 बीच में से चले गए, so that's 0.44 moles left, right?
Yes.
इसके 0 थे और 0.56 प्रोड्यूस हो गया, so that means 0.56, right?
0.56.
And this would be 0.56. अच्छा, what's your Kc expression
As
in
well.
this case? Expression बता दो क्या होगा? And remember concentration. मतलब वो 1 dm cube
Expressions
1 dm cube container. So again, it's
is the same thing.
so find. I mean, 1 dm cube का कोई divide करने का फायदा कोई नहीं है. वही चीज ही आएगी. अच्छा, but anyways, but do remember this step. Divide by volume. अच्छा, what's the expression for Kc? It's going to be 0.56.
Times 0.56 over 0.44 times 0.44.
अच्छा, I wrote 0.56 only once. तुमने कहा कि it's 0.56 into 0.56, right? I'm saying कि you don't need this other 0.56. Why don't you need this other 0.56?
You do, don't you?
It's इसकी state देखो. What is the state of this thing?
Oh, solids. Yeah.
ठीक है, solid का मैंने क्या बताया था? Its concentration is going to be taken as 1.
0?
नहीं, 1.
Oh, 1.
मतलब ये जो term है ना, concentration for a solid does not make any sense. ठीक है, क्योंकि उसकी
तो फिर आपको solid का करने की जरूरत ही नहीं.
हाँ वो तुमने वैसे ही कर लिया, लेकिन वो बाद में पता लगा कि it's a solid.
Oh,
So I mean,
okay.
I mean, even if you calculate the term concentration of a solid, the spacing in the solid remains constant. It's always tightly packed. तो इसलिए कोई फर्क वहां पे तो पड़ेगा नहीं. तो it's just going to be it's going to be taken as 1. This one would be taken as 1. So be careful about that. ठीक है?
Yes, sir.
चलो ठीक है, कल करते हैं. सही है.
No, all right, sir. Allah Hafiz.
Allah Hafiz.
Allah, sir.